Right, so I came across this talk on the audio behind Overwatch on the GDC YouTube channel, and they are basically explaining the challenges they had and what solutions they found in order to overcome the challenges that came with essentially the goal of playing by sound, which is the title of the talk here. And some of them are really well thought out, amazing solutions. But the one that I'm going to focus on, that these guys tackled, is the occlusion and obstruction system that they implemented, and I think it's really good. In fact, if you've played the game, you know it sounds amazing. But particularly the occlusion system is great. It feels natural, and it doesn't with most occlusion systems, they feel rather on-off, kind of Boolean switched. So whether there's a block or there's a wall in front of you, the occlusion is switched on immediately, and whether there's not a wall in front of you, between you and the sound source, there's no occlusion. And that's good to start off with, but if you have, say, an occlusion system where you are quite far away from the sound source, or the sound source doesn't sound like it's not in the same room as you, the listener, but it sounds like it is, then that can kind of distract the player. What it kind of does is it brings the player out of that sense of immersion. And I'm just going to highlight how Blizzard's, what they essentially did was they used AI paths. And the thing is with AI paths is that depending on how far the listener has traveled across the AI path, that will change the occlusion amount, which gives a more kind of dynamic occlusion rather than just an on-off switch. So essentially, I've explored that in Unreal Engine and Wise. So I'll just quickly go through some simple diagrams to explain what I mean. So this is normally how occlusion would work. First you'd have the listener, then you'd have a sound source, and given, say, we're in a room in a game, for example, we've got a couple of walls obstructing the sound source. Now, as you can see here, we have our listener, and usually how this is done is from the sound source to the listener, we have a line trace. It's invisible and you can't see it, but it is constantly there, and depending on whether this line trace hits something, that will switch on occlusion. Now, this is efficient, it's good for CPU, but it is very black and white. Now, what the guys at Overwatch, the Overwatch development team did, they used paths. Now, in Unreal Engine, a path that is followed by AI can be assigned to something called a spline. Now, this is basically, I'm just going to interchangeably use both of these terms, spline and path, throughout this video, but I just want you to know that I'm basically referring to the same thing. So, just as before, we have the line that is constantly there from the listener to the sound source. We've also got a spline path just here. Now, point A and point B are the closest points from the spline to the listener, point B being the closest point to the spline, from the spline to the sound source. So taking this into account, if we measure the distance along the spline from these 2 points, we get a value. Now let's say for simplicity, we have the length between point A and point B over the length of the entire spline, and we'll get a fraction of some sort. So here it is, the entire distance is covered from point A to point B, and it is equal to the distance of the spline path, therefore meaning it's 100%. Okay, so if we take this figure and we say, okay, so this sound source here is going to be, because of the distance, 100% occluded, then we can start to basically change this figure depending on where point A and point B are along the spline. Okay, so say if we just move along a bit. Excuse the, it's a pretty crap diagram, but it explains what I'm trying to demonstrate here. So point A, V point B, is covering roughly about 50% of the spline. So say we've got the start of the spline all the way to point A, that's about 25%. Same with, say, end of the spline point, sorry, the end of the spline going to point B is again roughly 25%. Okay, so we have 50% coverage, and because we are still occluded from the sound source to the listener due to these two walls here, then we are going to get a rating of 50% occlusion. All right. Okay, so what if the sound source came around this corner and was here, and the same with the listener? Well, there's still about, I don't know, 20 to 25% occlusion, surely. So wouldn't that still occlude? Well, no, because we're still tracking this line here from the sound source to the listener, and whether that's generating any, what we call in Unreal Engine, hit results, which it is here. So next one, because there are no hit results, even though there's distance between point A and point B, we are not occluding this because there's nothing here to obstruct the sound source's path to the listener. Okay, so this is essentially how I have implemented my system in Unreal Engine, and I'm just going to jump over to it now and demonstrate it. Okay, so I'm in 720p resolution just so everybody can see everything. So just bear with that for now. But yeah, don't hire me as a lighting designer because there are a lot of bugs. But it's good for purposes of this video. Alright, so here we have our sound source. Now the reason there's a speaker wedged into a car is because we're going to have the sound source play 3 different sounds. I'll just quickly jump to Wwise so you can see. So we have a car which is having an idle engine sound, some EDM music, and a voiceover from a poem which I will link down in the description. It's not me reciting a poem, I just got it from Freesound because I just needed something quick to demonstrate the occlusion system with. Alright, so you'll notice in this level we have our sound source here in this room, and we have our spline, and this goes all the way from this room to this room here, and then from there straight into this room here. Okay, so we have 4 rooms in total, and basically going back to this diagram here, depending on how far the listener has traveled along the spline, will then generate a figure of how far along the spline the listener has traveled compared to where the sound source is along the spline, and then from that calculate that distance, and then take that figure over the total distance of the entire spline, and that'll return a percentage value, and that is how much we are going to occlude the sound source. Alright, so I'm just going to quickly jump in and demo it, and then we'll talk about the scripting in a second. Alright, so I'm just going to mute it for now. Cool. Alright, so at the minute, I've just muted the audio, but we're going to test the previously explained system, which is this here. It's just a simple line trace going from the listener, point A, to the sound source, point B. And that is what this debug line is right here. Okay, so you can see that little orange square is basically where the sound source is, and the line ends at where the listener is, where we are in the world. Okay, so if I jump over here, remember how this is green. In fact, it was better demonstrated here. It's green because there's no hit result going on. It's just passing through air, as we can imagine this in the game. But as soon as we hit something, it's going to turn red because we found a hit result. Now, if I just quickly move over here, I'm going to tell you, we are red now because it has hit this wall here. Okay? And this is how most occlusion systems work, right, as I explained before. Alright, so I'm going to unmute the audio and we're going to hear what this sounds like with this, this system here, the simple occlusion system. Alright.
The start that o'er the teeming
Okay, so we've got some vocals.
With violent and flaming zeal,
We're about to occlude it.
Pygmalion doth a passion feel.
Okay, you hear that?
By his art. All men, as far as in them lies, create.
Okay, so that is how this system works, and you can see it's very on-off. It doesn't sound too bad from here, actually.
A block of marble was so fine.
Okay, that's cool, but that's not too bad. We've got the wall blocking, casting a sound shadow, if we want to call it that. But if I go to the next room, this is exactly the same. There's no difference. And if I go to the next room again, we would expect it to be more occluded because there's no doorway here. Then
so well the cunning artist wrought. All things within
it's the same.
But soon the marvel
it doesn't sound particularly natural. And then
speech. Indeed, the man
and then it's black and white. There's not a lot of variation there, and it gets worse when we go for something like this, which is a car, which is a continuous broadband noise. So if I just... you can hear that sweep. Black and white. There was a sweep there, and that's just due to an interpolation setting that I used on Unreal Engine, which just means it's going to go from on to off gradually, rather than just immediately with zero interpolation time. Yeah, you notice that it sounds a little bit natural, and that's what most systems use, but I'm going to demo this with Wwise using the Occlusion spline, i.e. this model that I explained before. So I'm just going to switch to Wwise, as you can see in the bottom left. Okay, so you might have also noticed that there was a figure in the top left changing, and that is a float value that is being returned depending on how occluded the sound source is going to be. And once we hit this room here, we are at 100% occlusion. Okay, so it's the same principle as this. Ultimately, being in this room here is the same as basically this model here, where it's 100% occluded, because the distance from point A to point B is the maximum distance that it can be, i.e. the distance of or the length of the entire spline. So that is what 100% would, that's how 100% would be calculated. But let's just, let's have a listen, see how it sounds. So we've got our Wwise. Now, going back to what I said here about we still take into account this line trace. Even though I've travelled a bit along the spline, because we're not generating a hit result, the sound source isn't hitting a wall, it's not going to give any occlusion figure. So as you see, it's not occluded and the float value is 0. But once it's occluded, with a little bit, and it's a bit more gradual. There we go. We have a dynamic occlusion system where it's not on-off. It actually changes over the distance that you travel, which is a lot more natural than if I just switch back to this way of doing things. Now, I'm not slating Unreal Engine and its and the audio engine in it at all. This is just a very efficient way of doing occlusion, but it comes at a cost of being so black and white. Whereas, if we go for Wwise, I do something with speech.
To buy it did a sculptor hasten. What shall my chisel now is mine?
It sounds a lot more dynamic and natural. And I'm just going to quickly walk you through what's being changed in Wwise. So this figure in the top left is actually affecting multiple things. So currently we have our 3 sound sources here, all under a switch. And I'm currently driving the high pass, low pass, and the voice volume. Oh yeah, this was just to compensate for the drop in volume that came from the attenuation that was being implemented here. But this is just so you guys could hear it. Otherwise, this would be down here, for example. But let's just not focus on that now. But also, we would drive the reverb send. Now, that is quite a lot of reverb, but the idea is that I made it sound obvious so you guys could hear it. All right. So that's what's being driven by this gain parameter in particular from the top left float value, which shows on tells wise how much we want the sound to be occluded by. Alright, so I'm going to quickly jump into the script of this. So just give me a second. Alright, we'll have the sound source. This is the first primary sound source that we use. I have three different blueprints because it was just a bit of experimentation to show you how this changed. This changed across me developing this system. So this is the first system where it looks complicated, but there's a lot of other stuff going on here, such as the GUI and all of that. But all you need to focus on are these little green commented boxes here within this blueprint. So first one is we find the pawn, i.e. us, the listener, within the level, and then we try and get the actor location of the pawn, and we're basically here just casting our debug line, which is this trace path here. Now this is the exact same trace path that would be used by Unreal Engine for their simple occlusion system, and that would give the on-off black and white occlusion that we were talking about before. But I'm using it here for this check that we discussed in the last one, where even though there's distance between point A and point B, because there's nothing occluding it, say if there is no hit, then what we do is we set the RTPC value to 0, and we are not occluding, and this is what you saw in the top left. But other than that, sorry, that's confusing things. Other than that, if we do have a hit result, say here from point, and then we take the distance from point A to point B, which is set here in my. I've done it through two blueprints, by the way. So this is the sound source blueprint, and then I use the. I have a spline blueprint as well, which is effectively this here. So all I'm doing is I'm doing everything through Blueprint. By the way, there's no C++ coding going on here, so it's actually quite it's, I would say, kind of simple. I mean, it's advanced occlusion, really. It's not just a on and off switch, but if you've got a bit of Blueprint experience, then you should be able to do this and demo it to your programmer, and maybe the programmer might say, all right, we'll include this in the audio engine. We'll hardcode that into the game engine, and then in a more efficient way than I've demonstrated here, because there could be, this is just one sound source. This isn't hundreds of sound sources or voices simultaneously going on at once. I mean, even if that was the case, you'd probably want to start culling those and to save up on the performance. But this is for if there are loads of sound sources, and it can be done because Blizzard did it. So I'm just going to quickly go through the sound occlusion spline as well. So here we get our pawn, our occlusion character, and then we find all of the sound sources in the world. There's only one, so we only need to get the first address of each because there is only one in the world. So we find the actor location, and then we find the location closest in the world to the spline. Now this then is something I found online, and this tracks essentially your progress or your distance, i.e. this point here, along the spline. Essentially, I'm cheating a little here. I got this from a forum because I don't 100% know what's going on here, just because I'm not sure exactly what find input key closest to world location is exactly, but that's something I need to just look into and I'll find out pretty quickly. But that returns a value. Come back to the event graph and we compare these two values here, i.e. the distance from point A to point B, divide that by the total length of the spline, and then that will set the source occlusion amount. Now going back to the blueprint, oops. Please don't crash. No? Yeah, alright. Panic averted. Set occlusion amount, that is this here. Source occlusion amount. So we're basically casting this to this blueprint, and we are then affecting our RTPC curve using this float value. Okay, so that is the basics of it. I don't think I need to explain anything else other than what you just heard there. But this is all well and good. This is cool. But this is only working for one sound source, one path, and one listener. What if we have more than one path? We're not just in a flat. We're in maybe a multi-story house, maybe something with 2 floors in it, and maybe there's more than 4 rooms, and there's more than one way or more than one path that the sound could take. Well, I'm going to show you that in this one here. So this map involves not 1 but 3 splines. Okay, so this is the upstairs area where the sound travel. Going up here, then we have the room directly above the sound source, okay, and then we have on the other side of the house, we have another room here. Yeah, I didn't texture everything, so just bear with that. But we have one more spline point which goes from this room here, like in the previous map, all the way around into this room here. Now, how would you manage more than one sound spline point then? So this is how I did it really. I compared all 3 values that get returned from all of these splines, and the one with the shortest, or the smallest float value, that gets returned to the RTPC curve for this sound source here. Okay, so this is ultimately what's happening. We're following the same principles as before, but all we're doing is the listener is finding the or the sound source is finding the shortest path to the listener via whichever spline point the listener is closest to, and then taking that and then sending that into Wwise, which then drives the occlusion amount. Okay, now some problems. Okay, so if I'm here, I start, or I just go upstairs, come around, and I am at this point here. Smallest occlusion value that's going to be returned isn't going to be from this spline, it's going to be from this spline here. Okay, so it travels from the listener to this point here. So what I had to do was I had to have another blocking system for if there is a something in the way from the closest point of the spline to the listener. If there's something in the way, if there's an imaginary line from the listener to the spline, then ignore that figure, ignore that spline, that's not relevant, and set it to the highest possible value it can be. Then that, in turn, it then defaults to the next nearest one, which would be this spline here. Now the thing is dealing with jumping between one and the other, because this spline might return a smaller value than, say, this one here. Now how do we deal with that? Well, when you jump between the two, it kind of snaps. That's the problem that I found originally. But there is a way of dealing with it, which is I thought I would be having to use an finterp2 node and doing some more scripting, and then I spotted that Audio Kinetics saved me again. Something really easy that you can just do is you just say interpolate. And this saved, this basically solved that problem. It's fantastic. And yeah, it kind of, that's a quick fix there. But there might be a better way that the programmer might come up with, or if you've got an audio programmer on your team, they might say, actually, there's a much better way of doing this. Maybe they, maybe it's more of an interpolation time. I'm not sure, but this is a quick fix that I just implemented here from switching between one spline to the next. All right. Okay, one final thing to cover is the spline lengths themselves are different. They're not all the same. So take this one here, the blue one. Okay, this is shorter than the green one. Excuse me, just from the just to the left of the blue one here. So this spline is going to be much longer, or a little longer even, than this one here. So notice before that if you cover 100% from point A to point B, then it's going to give you 100% occlusion. So what I did was I took said spline and I added a multiplier. So this can only go up to 85% occlusion, whereas this spline here goes up to 100%. So that's a multiplier of 1. And then going down below, I think this is the second. Oh, right, yeah, this is the shortest spline. So that gives about 80% occlusion from when you're at quote unquote 100% occlusion. Just because this path is shorter, it should not sound as occluded when you're at maximum occlusion for that spline. All right. Okay, so let's demo this. Did quick. I know this video is dragging on a bit, but I do want to just explain everything as best as I can so you guys can understand it and you know what's going on. Alright, so let's jump in. Oh, sorry, hold on. I'm at the... I'm on the wrong floor. Just quick. I'm going to quickly go here. Turn that around. Yeah, that'll do. Okay, whoops. Okay, well, just go with that. Right, cool. Also, I've drawn some debug lines between here. So this debug line is going from the listener, i.e. us, to the closest point on the spline. Okay, same going for the other two, the blue and the green splines. They are doing the same, the ones that go upstairs, essentially. And this yellow spline here just goes around to next door. All right, and we still have our trace here, which tells us whether we're occluded or not, and it will turn red, yep, like that, as soon as it hits that wall. Alright, so you know what's going on. Let me just quickly switch engine. Alright, we're using the Wise Audio engine now, and let's unmute it.
Manufacturers frown.
Okay, I'm going to go upstairs first.
Excess of faith, the poet once scarce fell behind. The hatred fearing and the wrath of God's the product of his mind. This trait we see in infancy, between the baby and its doll. Of wax or china it may be, a pocket stuffed or folded shawl. Imagination rules the heart, and here we find the fountainhead.
Okay, I'm just going to focus on one thing dead quick. Okay, so do you remember what I said about if there's a spline below us, it might try and latch onto that because it's closer and it gives a shorter or a smaller value of occlusion than, say, this spline here. Well, you see these orange blocks. That's indicating that these are essentially being blocked by this floor or the ceiling, and that will generate a higher 100% occlusion rate just because of that for that individual spline there. So this block is indicating that this line trace is going to the yellow spline, which is running all the way around the 3 rooms there that was on the ground floor. Same here. This is the green spline, I think. Yeah, because this one here would be the blue spline that comes around into the floor, the room above where the sound source is. And this here is showing us that actually the green spline, I'm forgetting my colours, anyway, the one that comes upstairs and goes over there to the other side of the house, that's actually the closest point is below us, but it is being blocked by this floor. So ignore that and do the same for the yellow spline, which runs across on the ground floor. So essentially, just take where, I mean, you've got to imagine there's a spline here. I didn't make it visible in the world, but this line trace here is going from us, the listener, to this spline here and generating the value in the top left of the screen, which is about 74.5%, okay, occlusion. And remember what I said about the multipliers. So if I go in here, this can only generate a maximum of 85% occlusion, okay? So let me jump over here, which is on the other side of the house, and therefore will give us 100% occlusion, like that. Okay, let's just jump back onto the stairs. Maybe you want to follow a certain curve as well, maybe use a curve asset in Unreal Engine, because I feel like this is a little under occluded.
A block of marble was so fine.
Yeah, it sounds a bit like it's there, so maybe for if it follows an upstairs path, it's going to be, it will give a maybe a steeper occlusion at first. Okay.
I'll arm it too with thunder. Let people quake and bow the knee with reverential wonder.
Notice how it jumped from 70% to about 60. That's it, jumping from this spline here to the one. So you'll see one of these jump. Yep, there. Jumped to this spline here, which is the 60% that we're following. And it sounds a lot better. There's a lot more. It's more dynamic. It's more realistic sounding than just this. So this is occluding, not occluding.
Wax or china, it may be, a pocket stuffed or folded shawl. Imagine, or folded shawl. Imagination rules the heart, and here we find the fountainhead.
So the reason I've turned it up is, as it's more occluded, is just so you guys can hear it more, as I said before. But yeah, let's try it with the music. And we have our car sound here. It's just a poem there that is on Freesound. Again, I'll link that below and credit the guy who did this. Okay, so cool. I think I've shown everything there that I need to. If you think, if you're thinking, well, is it worth doing this? If you're playing a first-person game, first-person perspective game, I think this is definitely worth doing. Something like Overwatch definitely needed a system like this because in Wise, you only get the one... in fact, hold on. If I can even find it, I think it's in user preferences. No, hold on. No, hold on. It's definitely somewhere. Whoops. Ignore that. Oh, hello. Anyway, so this is basically if you're working with Wise, you'll know the occlusion system is only limited to, I think, one occlusion parameter, I think, that you can set. But I think something like this, where it's not just an on-off switch, is much better than having something that's black and white, and it sounds more natural. And what's even better is you can tailor it for each sound source, the amount of reverbs, the low pass, the high pass amount, and the volume. And then even better, you can probably do it for different types of the same sound. So what Blizzard did was if it was an enemy's footsteps, you'd need to hear that more so than a friendly's footsteps. And that's already becoming an incredibly complicated system. And you'd need to manage that very well. And the guys at Blizzard did a fantastic job of that. But I think for something like this, it's definitely worth investing time into. All right, cool. Thanks for watching, and hopefully if there is a next video, I will see you in that.